All right, thank you for joining us today. And in this video, we are going to go through derivatives using the idea of the exponential function, right? And then also the power rule. So we've covered the power rule, we've covered the exponential rule. So we are going to combine them and then we use to solve examples, right? So as usual, I have like three sets and then I'll do the two. I'll leave the one for you to solve. Then you leave your results in the comment section. So now let's look at this. Write down the derivative of the following function. So you want to write down this function here, right? So now what will be y prime? So y prime will be equal to, so as I said, anytime you are differentiating a function and you see a constant multiplying the function that you are differentiating with respect to, that constant will just come in front. Then we differentiate the function. So the 5 comes in front and then we differentiate the s cube. And when I differentiate s cube, what am I going to get? So x cube using the power rule, this implies that 3 drops down, right? So the power here drops down, which is 3. Then I maintain the function again, 3x. So you see that 3 drops down, I maintain the function again, but power rule says that I need to subtract 1. And this is going to give us 3x squared, right? So this is going to give us 3x squared here, plus, now we want to differentiate es squared. What do we get? Now es squared, you can see that we are differentiating the function with respect to what? X. But this e squared here, did I say es squared? E squared here should be, or let me say, it does not contain the variable that we are differentiating with respect to. So there is no x here. So this is a constant. And when we differentiate a constant, what do you get? We get 0. So we are going to have 0. So take note of that. Anytime we are differentiating a function which does not involve the variable that we are differentiating with respect to, we are going to get 0. Unless we are in the case of, let me say, implicit. But even this one, if we are talking about implicit, so this one is going to be 0 because this is a constant term which does not depend on any variable. Now let's look at differentiating x to the power 7. So the same thing, 7 drops, I maintain the function x to the power 7, then I subtract 1. So this will be 7x to the power 6. So this will be minus 7x to the power 6. And I'm going to have, so 5 times 2 will be 15x squared minus 7x to the power 6. So this is what I'm going to get at the end of the differentiation. Now let's look at B. Let's look at B. B here, sometimes when you are doing derivatives, sometimes what you need to do is you need to simplify the function so that you make your life what? Very simple. So here what I'm going to do is I'm going to say that y is the same as e to the power 2x. Then I'm going to simplify what is here. Now 2 times root x can be written as plus 2x to the power 1 over 2, right? So if I have root of x, this is the same as x to the power 1 over 2. So I change this one to this so that I can apply the power rule to solve, right? So that's the reason why I need to simplify that one before I can do the differentiation. Minus 11. So now what will be y prime? Now what will be y prime? Y prime will be equal to, now we learned how to differentiate the exponential function from the previous video, right? Or I have a video on that, so you can check it out if you want to learn more or you want to understand how to differentiate this more. So when I want to differentiate this, it's very simple. What am I going to do? I will just drop here, like I'll pick the 2x here and then differentiate. So what I'm going to do is I'll maintain the function times. So this is how we differentiate it, even if I'm not checking the video, but you can go and check it and learn more. So I'll maintain the function if I want to differentiate. Then differentiate the one on the top. Yes. So what did I do? I maintained the whole function here. Then I differentiated the one on the top. So if somebody is doing it and have watch the video in the previous, you'll be like, okay, this one is going to be 2e to the power 2x, because he knows that I maintain the function or I differentiate the top. Then, so let me turn it around so that when I'm writing it, it will be nice. So I differentiate the top, which is 2x, times, then I'll maintain the function. Very simple. Then plus 2, so power rule, this is constant multiplying this. So I maintain my 2, then I differentiate what is multiplying the 2. So x to the power 1 over 2, power rule says that 1 over 2 drops down. I maintain the function, but I subtract 1. So this is going to be 1 over 2. Now half minus 1 is the same as minus half, right? Good. So that's what you're going to get. I'll do videos on how to do fractions for you to understand. So this is going to be 1 over 2 x to the power minus 1 over 2, and then when I differentiate a constant, I'm going to get 0, so minus 0. So that's what you're going to get. Now let's simplify. When I differentiate 2x, as I said, 2 here is a constant multiplying the function, so the 2 will come, right? Then I will differentiate x. Now we know that when I differentiate it, I'm going to get 1 e2x, then plus this 2 here will cancel this 2 here, so I'm going to have something like x to the power negative 1 over 2 minus 0. So that's what I'm going to get. So when I simplify it, I'm going to have 2 this plus, I can write this one as 1 over x half, 1 over x 1 half, and this is the same as 2e2x plus 1 over root x. So this is what I'm going to get at the end of the differentiation. So the key thing here was you need to simplify this, write it in this form so that you can use the power rule to work with. Good. Let's look at the C. Let's look at C. Now the C here is, you need to simplify anything? No, we don't need to simplify anything. Why? Because this is a constant, so I don't need to even write it as 2 to the power 1 over 2 because it's a constant, and I know that when I differentiate a constant, I get 0. So I don't need to differentiate anything. Now, there is something that I want to show you here, which I didn't talk about. Now, when you see something like this, now something like this here is like you have an exponential function, but this is x, this is also x. This is x and this is also x. So if that's the case, then how we are going to differentiate this will be different, right? So let me take it one by one and let's see. So now y prime will be equal to, now remember e is a constant, so it's like you having x squared. How do you differentiate it? It will be 2x squared minus 1. So if I want to differentiate e to the power x to the power e, this will be e dropping down, then I maintain x to the power e, then I subtract 1. So that is how the differentiation is going to be, because e is a constant term. So I'm going to have ex e minus 1. Now minus 3, then I need to come and differentiate x to the power 10 x. I'll talk about this, but before I talk about this, let's look at this function here. Now when I differentiate that one, I'm going to get 0. Now let's talk about this function right here. Now if I want to differentiate this function here, this function here is x at the down, and then we have 10, and then we have another x here. I have a video that is coming up that talks about when the base is not constant. It's not constant, right? Good. The base is not constant, and we have a function on the top too, which is also not constant. So how are you going to do this? Anytime you see function like this, what I'm going to do is I'm going to let y to be equal to 10 x to the power that. Now, since the base is not constant, I'm going to apply the idea of the natural logarithm, which is ln y to be equal to ln of x 10x. Then what I'm going to do is, now I apply the properties of len and then make sure that this one goes down. So I'm going to have len y to be equal to 10x len x. Good. So this is what I'm going to get. And then from there, what I'm going to get from here is, now I need to now do the differentiation. So one thing that you need to learn is, when I want to differentiate a len function, I'll talk about len function too. When I want to differentiate a len function, I put the function in what? Parentheses, so that you can grab the idea that I'm coming to talk about. So to differentiate a len function, this is how I go, like, this is how I explain. It's 1 over what is inside the parentheses here times the derivative of what is inside the parentheses. So 1 divided by what is inside the parentheses times the derivative of what is inside the parentheses. So mostly, instead of writing something like this, I do it 1 divided by x times the derivative of what is inside the parentheses. So I put the prime on here. So when you see something like this, I'm differentiating. So this is going to be 1 over x times, when I differentiate x with respect to x, I'll get 1. So the same thing here. So this is going to give us 1 over x. So that's the idea where, like, when they ask you, when you differentiate len x, what do you get? 1 over x. But you need to know the process so that when the function is not just x, you won't go and say that so let's assume that if the function is, let's say, 3x plus 1, 3x plus 1, you are not going to say that the function, when you differentiate it, you are going to get 1 over 3x plus 1, because I know that when I differentiate len x, I get 1 over x. So it's like 1 over what is inside the parentheses. So this one will be 1 over what is, no. Remember, you would differentiate what is inside the parentheses. So this one, when I do it, there will be 3 on the top here, because I need to differentiate what is inside the parentheses. We will talk more on len, so don't worry about that. So yeah, so that's what you're going to get. So that is the idea. So it means that if I want to differentiate len y, then len y will be equal to 1 divided by what is inside the parentheses, then times what is inside the parentheses prime. So this one will be 1 over y times y prime. So that will be the differentiation for len y. So I'm going to get 1 divided by y times y prime, which is equal to, now this one I need to use the product rule. I need to use the product rule for differentiation. So what I'm going to do here is, I'm going to maintain one of the function. So let me clean this one up. Good. Now when we talk about the product rule, we have two functions. So I have this function here and I have this function here. So I'm going to name them. The first one is a, the second one is b, then x. Now what will be a prime? So when I'm differentiating this, 10 is constant. As I said, I maintain it and I differentiate x. I'm going to get 1, which is going to be 10. Then what will be b prime? Now we learned just now that when I differentiate len x, I'm going to have 1 over x. So what I'm going to do is I'm going to do cross multiplication. So this a prime, a will multiply b prime, and then b will multiply a prime. So that's what I'm going to get. So with the differentiation, I'm going with this times this. So I'm going to have 10 len x plus, then this will multiply this, which is going to give us 1 over x times 10x. So when I simplify from here, when I simplify this one, I'm going to have y prime over y, which is equal to 10 len x plus, then x will cancel x, so I'm going to have plus 10. Then what will be y prime? Y prime here will be equal to 10 len x plus 10 all times y, because now I need to multiply this one by y. So this is like this is divided by 1. So 1 times y prime will be this, and then y times this one too will be this. Now what is y? What is y? Y is equal to what is here. So we said let y to be equal to this. So now we know y to be, so this one will be 10 ln x plus 10 all times y, what is x to the power 10x. So this will be the derivative of this function, which is equal to y. So when I differentiate x to the power 10x, this is what I'm going to get. So I'm going to replace here by this function right here. So I think I need to move this once more. So I'm going to have 3 times 10 ln x plus 10 x to the power 10x. Right. So that's what I'm going to get. Then let me add the last term to it. The last term was when we differentiated root 2, we had 0. So when I simplify, I'm going to have e x e minus 1. Then when I multiply 2 by 3, I'm going to have minus. So I'm going to multiply this by this and this. So I'm going to have minus. So let me leave the minus out. I'm going to have 30 ln x plus 30 or x to the power 10x. So this will be the final result for differentiating this. Good. So that's what you're going to get from this. Yeah. Now let's look at the next question. So the next question is also the same form. I'll do this one, then I'll leave the next one for you. Then you put your results in the comment section. So let's go through this one very fast, since now we know how to do the differentiation from the first one. So now y prime here will be equal to, now we have pi. Pi is a constant. So this is going to give us pi, then x pi minus 1. When you differentiate it, that's what you're going to get. Plus 10 out. When I differentiate x squared, I'm getting 2x. Minus, when I differentiate x to the power 3, I get 3x squared. Simplify, we get pi x pi minus 1 plus 20x minus 3x squared. So that's what we're going to get from there. Also, this one, we need to make our life very simple. So this one can be written as 6x to the power 1 over 3, because cubic root of 3 is the same as x to the power 1 over 3 minus 7 plus e to the power 4x. So that now I can differentiate using the power rule. I maintain my 6, 1 over 3 drops down. I maintain x to the power 1 over 3, then I subtract 1 from the power rule. When I differentiate a constant, I get 0. Plus, when I differentiate this, the 1 in front comes down. So I'm going to have something like 4e4x. So you see that what is here in front of the x is the same thing here. So like when you want to differentiate something like this, just pick the coefficient of the x in front. This happens, what I'm talking about happens when this is a linear function, right? This is just x, right? So if this one is just x, then that's true. If a linear function, like the top here is a linear function. When is a linear function? A linear function is with order what? 1, or the degree of 1. So when it's a linear function, then just pick the coefficient here. So if I want to differentiate something like e to the power minus 2x, then this one will be minus 2e minus 2x. What did I do? I just pick the coefficient of what is here, and then I put it there whenever it is a linear function. So I can also talk about minus 3x plus 1. Still, the top here is a linear function. So I just pick the 1 in front of x. So this one will be minus 3e minus 3x plus 1. So that is the idea of differentiating exponential function when the top is a linear function. Very simple. So now let's simplify. This is going to be 2x. So this time this will be 2. And then this here, 1 over 3 minus 1. Now this is the same as 1 over 3 minus 1 over 1. Then this is my trick of doing the multiplication. This one here will multiply this. Always here goes with this one first. So 1 times 1 is 1 minus 3 times 1 is 3 divided by the denominator. When you multiply the denominator, which also 3. So this is minus 2 over 3. This works for all fractions. Anytime you want to, simplify a fraction. So this one first multiplied by this. If it is plus, you put plus. If it is minus, you put minus. Then this times this, then divided by this times that. So this is the pattern. It's like so if I want to do it in a pattern form, I can go like this times this, then this times this, then this times this. So it goes like this. From the top, multiply by this. Then when you move up here, this one will multiply what is here, then this one multiplies. So if you can look at the pattern, that's how it's supposed to be. Good. So let me do the pattern very well. So this times this, then this times this, then you multiply. You divide it by this multiplication. That is the pattern for fraction. Good. So that's what I'm going to get. So this one is going to give us minus 2 over 3 and then plus 4e to the power 4x. So if I want to further simplify, this is the same as 2 divided by x to the power 2, this plus 4e to the power 4x. I'll stop it here. Now let's look at this one too here. I don't need to simplify this because I know that this is the same as 6 to the power 1 over 2, but this is a constant. There is no x. So when I differentiate, I get 0. So I don't worry about that. So y prime will be equal to 0 plus. Now, whenever I have a constant multiplying the function that I'm going to differentiate, I just maintain the function. Then since the top is linear, you just pick the coefficient of the x here, which is 2 times the function. That's all. So 2, which is right here. Then minus, if I want to differentiate this, 11 drops down, then I maintain x to the power 11, but I subtract 1. So I'm going to have 14 2x minus 11 x to the power 10. So that's what you are going to get at the end of the day. So the next question, I'll just give it to you to try. So okay, so this one you try them, then you put your final results in the comment section. So we have this function right here, right? And then we have this function also here, and then we have this function also right here. So try and differentiate it and put your final results in the comment section. See you in the next video.